Today we are going to learn about this 8x8 LED matrix and how does it work. And we can display various kinds of visuals like letters, digits, emojis like this smiley, and even the scrolling text. So let's start the video. Now before moving further, let me discuss about the pinout of this 8x8 LED matrix display. So if you see at the back of the display, there are a total of 5 pins here and 5 pins here. So VCC and ground are obviously for the power. DIN stands for data in, which will be coming from the microcontroller like Arduino. CS stands for chip select and CLK stands for a serial clock, and this pin is used for the synchronization between the data of the microcontroller and this display driver IC, because it is the only IC in this LED matrix which is very important, because it is accepting the data from the microcontroller and also it is controlling all these 64 LEDs. Okay, so synchronization is very important here. And now these top 5 pins are used when you want to stack up more number of 8x8 LED matrix in series with this one. But in this project I am going to use only the lower one. Now if you look closely here, these 64 LEDs are connected to this IC only through these 16 pins. 8 on this side and 8 on the opposite side. Okay, these are those pins, 8 here and 8 here. So how are we able to control all these 64 number of LEDs with only these 16 pins? So to answer this, let us move on to the computer screen. So in this image you can see that how all the 64 LEDs are connected to each other. So they are connected in vertical and horizontal arrangements. So I'm calling the horizontal arrangement as rows and vertical arrangement as columns, right? So an LED has two terminals, anode and cathode. So the LEDs which are present in a single row, in a particular row, the anodes of those LEDs are connected to each other. You can see the little dots here. These are representing that the anodes are connected to each other. But you can notice one thing here. The anodes of one row are not connected to anodes of any other row. And same goes for cathode. The LEDs which are connected in a single column, the cathode of those LEDs are connected to each other, but the cathode of a single column are not connected to cathode of any other column. So that's how they are connected to each other. Now in this arrangement, total 16 pins are there, 8 on this side and 8 on this side. Okay, and these pins are not corresponding to the actual pinout of this LED matrix. I have numbered these pins only to make you understand about this display. So suppose I want to control this LED here. Okay, so I need to control the pin number 6 and pin number 4. Then I will be able to turn off or turn on this LED. Now these 8 pins and these top 8 pins are connected here, right? These 8 pins and these 8 pins. And these are also connected to this side of the display driver IC, which has 12 number of pins. And this display driver IC is smart enough to take the input from the microcontroller using this single pin DIN, and it can control all the 64 LEDs using these 8 pins and these 8 pins. Now let us understand that what kind of data is actually required by each of the LED in order to turn off or turn on. So they require binary data. 0B is representing that it is a binary data. And why binary? Because an LED has two states, either turn off or turn on. So on represents 1 and 0 represents off. Okay, and don't confuse that this data is being outputted from this IC MAX7219. No, actually this data is being provided by the microcontroller to this IC using this DIN pin. This is just a visual representation that how each of the LED is being controlled. Now suppose I want to display letter T on this 8x8 LED matrix. So what I've done here, I have lit up all the LEDs in the first row and the second row, and the middle two columns are also turned on. So you can easily observe that the LEDs which are turned on have the value 1 in their binary data. Okay, these values are 1, these are 1, and the starting 3 LEDs are turned on. That is why they hold the value 0 in the starting 3 LEDs. Okay, and the middle 2 LEDs are turned on. That is why these are 1 in each of the rows. So that's how we can control each of the individual LEDs. So this is the program to display the letter T and digit 6 on the 8x8 LED matrix. And in this program I am importing the LED control.h library. So this library takes 4 parameters as its input. The first one is a DIN pin. So DIN pin is going to be connected to pin number 7 on the Arduino. The second parameter is a CLK pin, serial clock. Okay. The third parameter is CS chip select, and the fourth one is the number of LED matrix. So I am using only one LED matrix, that is why I am using here 1. Now these are the bits information for displaying the letter T. And you can see I am turning on all the LEDs in the first row and the second row. And the middle two columns are also turned on. And rest all other LEDs are turned off. Similarly, these are the bit information for displaying digit 6, and you can change these bits according to your requirements. Now in the setup function I am calling the LED control library. First of all, I am waking up the MAX7219 IC to ensure smoothness of the display of the digits and letters. Second one, I'm setting the brightness of the LED matrix. So the maximum LED brightness can go from 0 to 15, and I'm setting the brightness to 10. And last, I'm clearing the display so that the digits and the letters should be displayed from the starting. Now in the loop function, I'm running another for loop from 0 to 7. Okay, and what this line is doing basically, it is setting the each of the LED in the particular row. Suppose in this first row all the LEDs are turned on, so one by one each of the LED will be turned on, right? So this line is basically used for a particular row and not for the entire 64 LEDs at the same time. And if you want to display the date 6, you can uncomment this line and comment the letter T line. Now you may ask, how do we control each row and each column of this LED matrix simultaneously? So we don't control the rows and column in this way. What we do instead, suppose I want to display the letter T on this LED matrix. Okay. So first of all, I will turn on the LEDs in the first column. Okay, like this one, these two LEDs. Then by keeping turning on these LEDs, I will also turn on the LEDs in the second column. Okay. And then I will turn on the LED in the third column, then in the fourth column. And this process of turning on and turning off the LEDs is so fast that human eye can't detect it. And that is why we think that each column and each rows are lit up simultaneously. But what is actually happening here, each column is being turned one by one and not simultaneously. So if you enjoyed this video, don't forget to like this video and subscribe to my channel so that you never miss my latest video tutorials. And if you have any doubt regarding this project, comment in the comment section. And let us meet in the new video with the new project. Till then, goodbye and keep learning.